Final Presentation Group 9, Intelligist or Intelligent Gesture. The project idea is about developing a versatile mode of control to smart devices and physical objects around us. It's a lightweight glove that gives the user the freedom to map gestures, in this case hand movements, to desired actions. And they do that throughout using an application program interface, or simply an API, that comes along with the project. That way, the user have full control over what each gesture does, so that way it offers customizability, which is not found in similar projects. The motivation behind this project is to enable the control of remote objects with an intuitive mode of control, that way it's just hand movements, and helping people with limited movement to control everyday objects around them more easily. We're thinking people with disabilities who have restricted movements and can't simply go around and control objects easily as they would like to and become dependent on others. So this is something that we can basically resolve by giving them such a simple intuitive mode of control. It also has the flexibility. The project offers the flexibility and the customization that comes with the API by mapping the desired actions, as mentioned, to hand gestures of choice. The essential features in this project is that we've utilized Arduino and Raspberry Pi capabilities to recognize the hand gestures, and at the same time, what you can hook up to the glove and the API is anything of choice. So in that way, you have a broad spectrum of possible applications. More in the design to come.
So the design of the glove was to have sensors on the glove itself to determine what the user's hand inputs were, which would be interpreted by the Arduino Nano that we attached to it, which would be sent over an ESP8266 Wi-Fi shield to a Raspberry Pi, which would act as the server, so we could get commands sent from the glove to the object that we're trying to control via the Raspberry Pi. Obviously, we didn't get to implement the last bit of that. We were able to get signals from the glove to the Pi with interpreted hand gestures, as we'll show in the video following this, but we were unable to have time to set up test cases like the drivable cars shown in the slide that we were going to set up due to the unexpected stopping of the hardware part of the project. So, as we can see here, we find the glove with the sensors wired up, so we see two flex sensors hooked up on the glove, which went to the Arduino Nano we can see on the board, as well as the ESP8266 wired up to that, which sent the data over Wi-Fi to the Raspberry Pi. The flex sensors, well, actually we'll be covering that on a later slide, so I won't go into detail as to how those work yet. So as we can see in this video, which is actually not the most updated video, we added in more gestures and more complete transmission of it. We switched transmission of the gestures into a number format so it would be easier to interpret them. But unfortunately my camera quality wasn't good enough to capture that, so at least to capture it with the differences being visible on screen, so we're going to be showing this video instead. As soon as I can get it to play. There we go. So as we can see, as the hand gesture changes, we see the change reflected in the output of the Raspberry Pi shown on that terminal. So the design of it was actually to hook the flex sensors up via a voltage divider, as the flex sensors are operated based on resistance. So as the sensor bends, the resistivity of it increases, so we can use that in tandem with a voltage divider circuit with, I believe it was 47 kilo ohm voltage or resistors to set up the voltage divider with, and then those would output an array of degrees, so we could map the fingers to a specific gesture. And then the other chip we see on the far right is a 3-in-1 accelerometer and gyroscope, which we were going to attach to the back of the hand to track the orientation of the hand as well as the direction it was moving in. And then those would all be hooked up to the, well, the accelerometer was going to be hooked up to the, I believe, digital ports, and the flex sensors as well to analog ports on the Arduino Nano.
The glove operates on the network. To query the API, the user script must connect to the IP address of the glove. Then, it can start querying the microcontroller. Our API provides two endpoints for a user to use. The first one involves predefined and user-defined gestures that are saved onto the microcontroller. To listen for events, the user can simply connect to the gestures endpoint, which provides the current detected gesture with a timestamp. If the user wants to utilize the sensor data from the glove, he or she can listen to the raw endpoint, which provides all flex sensor, accelerometer, and gyroscope readings. Once the user is connected to the glove remotely, he or she can use a client to create a new gesture. To create a new gesture, the user can simply enter a name, hold the gesture, and then click Save. The gesture will then be saved onto the glove's microcontroller. Creating a gesture with movements is also easy. The user can start recording from the client to create a timeline of movements from the glove. Once this timeline is saved, the user can trim it to select the desired time frame. So, as an overview, the gesture API is useful if the user wants a fast setup where he or she can easily add new gestures. If the user wants to utilize all the sensor data, then the raw endpoint provides that flexibility.
The prototype for this project cost $160 in total, and this included things such as extra parts, trying different kinds of hardware, and shipping costs. Companies interested in using the glove with their product can be given access to the API, and given the versatility of control, the glove can ideally be integrated with a variety of uses like home automation systems.
And on the topic of evaluating other tools, yes, there are inventions that exist that involve gesture protocol, but most of them are used within a commercial setting. For example, there are people that are using gestures to control cars, and tech companies that will sell their technology and all their data to other companies that need gesture protocols. Our intention is to make the glove programmable by any consumer.
The main challenge in our project was with communication between the Arduino and the Raspberry Pi. To connect the two devices, we used the Wi-Fi shielded on the Arduino to send data to the Raspberry Pi through TCP server-client communication. Then, to connect to our Wi-Fi, which was RU Wireless Secure, we had to change the authentication certificate and configuration file in order to connect successfully.
So the summary of our work is that we were able to install communication between the Arduino, which is on the glove, and Raspberry Pi, which is installed on the laptop. We did that through TCP communication, in which the Arduino sends data that we get through flex sensors to the Raspberry Pi so that the Pi can extract all the data and map it towards gestures, which is then mapped to an API that is programmed by the user. And one example of how we're going to show our success of the work was through an RC car demo. So as of right now, we only have 2 flex sensors installed on the glove, and we have shown that it works. However, all we have to do is attach the 5 flex sensors onto the glove, and in doing that, we will recognize all the other gestures. So there are other possible applications besides an RC car demo. For example, we have a capability of using APIs with a wheelchair to have it move forward, backward, left and right, etc. We can also use it with Google Home or Spotify to do pause, play, fast forward, and rewind, and things like that. So if you see here, there's a lot of possibilities.
Thank you for hearing about our project, and we'd love to hear about any suggestions, feedback, or questions that you may have.